Alright. So we are doing the addition of vectors. If there are two vectors or three vectors, can we add them together? The addition of vectors is possible, but graphically we'll understand this better. And then we'll also see the numerical addition of the vectors as well. Let's see, this is first vector AB bar. You see this is the vector AB bar. The second vector is AC bar. And the third vector is BC bar. Now if I add the two vectors AB bar and BC bar, AB vector plus BC vector, then the resultant is the vector AC vector. The logic is very simple. You start one vector, where it stops, terminates, the second vector must start. Where it terminates, the first initial point and the final termination point will be joined by the resultant vector AC bar. So we can say AC bar is equal to AB bar plus BC bar, and then we can see this AB bar plus BC bar is equal to AC bar. We can see this is 3 and 1 AB bar. BC bar is minus 2 and plus 2, and then addition will be 1 3 AC bar. You add them together, you get 3 plus minus 2 minus 1. 1 plus 2 is 3. So you get AC bar is 1 3. So we have AB bar plus BC bar equal to AC bar can be verified as well. So this can be done graphically, and this can also be verified by the logics that we have with the vector column vector. So if you add the two vectors which are corresponding to x1 y1 and x2 y2, then their addition will be x1 plus x2 and y1 plus y2. Subtracting vectors is, again, it's that's not a separate topic actually. It's very simple. AB bar and BC bar, if I have to not add, I have to subtract. So I want to do AB bar minus, I have to do AC bar minus AB bar, let's say. So I write AC bar minus AB bar. Then I write AC bar as it is. And the negative vector here, minus AB bar, I will just write, instead of minus, I will write plus and then in bracket minus AB bar. AC bar plus minus AB bar. What is the significance of this? What do we achieve by doing plus and minus? This will be done by the addition of vectors. And what is minus AB bar? Minus AB bar is the negative vector which is in the opposite direction. Please check this. If this is AB bar, then exactly opposite direction and the same length, such a vector is called as minus AB bar. If this vector is AB bar, this vector is minus AB bar. The vector which is going absolutely in the opposite direction and has the same length is called as negative vector, minus AB bar. So you find out the minus AB bar first, and then AC bar and minus AB bar can be added and you get the final result. This can be shown diagrammatically as follows. So the subtraction of vectors AC bar minus AB bar, AC bar, AB bar, we do minus AB bar here and then we can subtract them and we'll get this. We can do this by x1 if the vectors are represented by x1 y1, second vector is represented by the column vector x2 y2, then subtraction of them will give us a column vector x1 minus x2 and y1 minus y2. Simple examples to solve. We given the vectors, we are asked to vector check AE bar plus EC bar. AE bar plus EC bar is equal to AC bar. DB bar plus DE bar is DE bar, and so on. Vector A, vector B are given column vectors, and then we have to find out A plus B, A minus B, 3A, 4. Very simple, we can do that. Let's see something. Yeah, this exercise you can check that P vector P is given, vector Q is given. You can find out 3P, P plus Q. Simple, very simple exercises, very simple questions. Magnitude of a vector. The magnitude of a vector is the length of the vector. On the graph paper that you show, if you show the vector of certain length, the length of the vector is the magnitude of the vector. You can use the notation modulus of AB vector or modulus of AB bar, or you simply write A if you want to write the magnitude of AB bar. We can use the Pythagoras theorem to calculate the magnitude of vector. In general, AB vector is x, y column vector, then AB vector magnitude is equal to x square plus y square. How is this right? Let's see this very quickly. We know that this is our vector. So this will be x and this will be y for this vector AB. And then we write AB bar using our notation x, y. This is the column vector. Now if this is true, then this is x and this is y. And this is the length of the vector, which is the magnitude of the vector. So the magnitude of vector AB bar is equal to this length. But this length is equal to, using Pythagoras theorem, we can get x square plus y square under root. This is exactly what is being written here. So you can get the magnitude of vector. Magnitude is always taken as positive because we are talking about the length. Length will not be negative. Positive position vectors. The vectors which indicate the position of a certain point with respect to the origin is called as position vector. For example, if this is the point A, then the position of that point A is indicated by the vector OA bar. O is the origin, and origin is always where the x and y axis meet, 0, 0. So the position vector of A is OA bar. Position vector of B will be OB bar. OA bar can also be written as small a. OB bar can also be written as small b. Here we get A, B and O, OA bar, OB bar, and we can get the vector AB bar. The position vector of A is 3, 2. The position vector of B is -2, 4. Find the vector AB twice of AB bar. First we'll find out AB bar. It is very simple. We can get that OA bar plus AB bar is equal to OB bar. Wait a minute, let's see this. I'll write this. Yeah. So we already know that this vector OA bar plus AB bar is equal to OB bar. So the vector OA plus AB is equal to vector OB. We know OA bar and we know OB bar. That is already given. Position vector of A and position vector of B. So AB bar would be equal to OB bar minus OA bar. And OB bar is -2, 4 minus 3, 2, which is equal to -2 minus 3 and 4 minus 2, which is equal to -5, 2. That is AB bar. You see AB bar 1, 2, 3, 4 and 5. 5 on the left, so x is -5. And 2 on the right, 2 on the upside of the y-axis. So it is +2 on this side. -5, 2. So using position vectors, we can solve these. There are some more examples, and this is the last exercise. The exercise is very simple as well. I would like you to watch this video. I would like to just take the examples from the exercises. Just solve the exercises. They are very simple. Just solve them for once. You'll be very good with vectors. It is very simple chapter. That should not be a big deal at all. I hope you enjoy this. I hope you like this. I hope this helps you. We'll see you when we meet. Thank you.